The purpose of this tutorial is to explain the difference between unseeded, globally seeded, and locally seeded runs within ExtendSim. The default behavior for simulation is unseeded, meaning the results of every run are going to be different. And the random number seed, which actually still exists, is pulled from ExtendSim or by ExtendSim to be something that's unknown according to its internal algorithm. So if we run over and over, what we'll see is different results each time due to the lack of random number seeding. We run and see that the first time we ran or the last time we ran this, we got the total number of departures was 2024. If we run again, now we see that it's 2048. If we run again, it's 2116. So we get different numbers each time. So that is the unseeded condition. Now, if we want to be able to get the same numbers each time we run for this total output, we set up seeding within the simulation setup menu. So we get to that by the run menu, then simulation setup, and we create the seeding by using any number we choose here. Doesn't matter what we type in. And then we click OK and run. Now this time we'll see that we got 2053 as our random value for our ending metric. If we run again, we will still get 2053. Now I'd like to point out that what this does is goes through each of the blocks and individually seeds those blocks. So even if the two blocks are identical, so in this example, we have two identical create blocks. So we notice that they're set up to be exponential of mean 1. And here we have another create block, which has the exact same settings, which is exponential of mean 1. If we go back into the plotter, we'll notice that they don't overlap, as we can see on the graph, but when we look at the data, we can really see that those arrival times are not the same, even though they've been set up with a global seed. So the two blocks are acting independently. Now, when we run this over and over, when we open up that data, we will see the same numbers coming out of each of these input streams, but the input streams are not identical to one another. So the blocks themselves are functioning independently. Okay, so that is that is global seeding. So we are seeding in a way that impacts the entire model at once, but it impacts each one of the blocks independently. So what this does not allow us to do is isolate the effects of whatever calculation we have downstream from the input stream that we're using, creating a paired experiment. If we want to do that, we need to actually seed the blocks locally instead of globally. And that will create inside this chart identical input streams. So the first thing we need to do is turn off the global seeding. And we do that by just 0 or blanking that out. And now we're back to getting a different value than we did last time we ran this. So to create the local seeding, we're going to go into each block individually that we want to create, essentially create identical streams of random numbers. And we're going into the options. In this particular block, the alternative to have the random number seed is on the options tab. Sometimes it's on the front. Any block that has the ability to generate its own internal random numbers will have a checkbox somewhere that says use block seed. Doesn't really matter what block seed we pick, but if we want the two blocks to be identical in behavior, we have to use the same one. So notice that this is just set up randomly to be 4 as a default. So we hit OK. Then when we go to the second block that we want to get the same output from, we're going to go to the options and we're going to set the block seed to be the same thing. And then check the use block seed on that block as well. Now, when we run, we'll see that the overlap is complete as far as the graphics. And if we look at the actual data, if you look and compare the data between run 1 and run 2, I'm sorry, not run 1 and run 2. I misspoke on there. Meant input stream 1 and input stream 2. That data for input stream 1 and input stream 2 is the same. And that is the entire point in doing the local seeding. That now allows us to compare anything we have happening different in these two input streams and know that the effect is not due to the timing of the incoming items. This ends the tutorial. Thank you for watching.